wanted to give another example of a combined gas law problem. And the other one wasn't truly one. I was going to do number 3 from the homework packet because it had a correction that would make it easier. This temperature is not on that chart. So you can make this correction. If you've already done it, and used this temperature and found that evaporated that pressure from the evaporated water, you can use that. So that's perfectly fine. Just be a really large number. But what I'm going to do is I'm going to change this to our number that's on that chart. I'm going to change it to 30.4 degrees Celsius. 30.4 degrees Celsius. So that would be the temperature 1. Okay, volume 1 would be 372 centimeters cubed. And the pressure would be 111 kilopascals. So we can put our pressure 1 would be 11 kilopascals. What volume, so we're looking for the second volume, would the dry gas be if it was T2 was 12 degrees Celsius and our P2 was 740 torr. Now different units of pressure. Get some more practice converting those. So, of course, the equation is pressure 1 times volume 1 over pressure 2, over temperature 1. And that would be equal to your second pressure, second volume over your second temperature. Since we're looking for volume, we want to get that by itself, so we multiply both sides by T2, divide both sides by P2, cancels over here, so our volume would be equal to our temperature 2, pressure 1, volume 1 divided by temperature 1, pressure 2. Yeah. A couple things, our temperatures have to be in Kelvin, and of course our pressure, we want to subtract out that extra water vapor pressure from the chart. I did put these on. There's in the notes, but here's another one. So if it was 30.4, that would be, it's in torr, so that would be added pressure of 32.561. 32.561. Remember that? So if we came over here at 30.4, it'd be, what was it? 32.561 torr. Okay, so we might as well convert this to torr. So I'm going to do it right here. Divide by 101.325 kilopascals, multiply by 760 torr. That would give me a P1 pressure of 111 times 760 divided by 101.325 equals 832. So it's a higher temperature, higher pressure. 832, 833 actually. 33 torr. Pretty high pressure, so we want to subtract 35.561 torr. So just subtract that right from here. 35.561. Let me double check my 32.561. Yes. Always good to double check your work. 35. Crap. Let's try that again. Plus 35.561. So I'm going to subtract. Should be 32.561. There we go. So that should be P1 of 800. Zero a little nicer. 800 torr. Okay, so that'd be my P1. Okay, so now we can plug all this in here. I'm just going to V2 is equal to P1, 800 torr, P1 minus the added water vapor pressure, times T2, which we'd have to convert this to 273.2, add that to Kelvin, so that would be 285.2 Kelvin, right? My V1 is 372 centimeters cubed. My T1 I need to put into Kelvin. T1 plus 273.2, that would be 303.6 Kelvin. And my pressure, which is in torr here, 740 torr. Cancels, Kelvin cancels. Have centimeters cubed. Yes. Now, just plug it into the calculator. I have my 800 times 285.2 divided by 740 divided by 303.6 and times 372 gives me a grand total V2 equals 378 centimeters cubed. Try those, a lot to think about, but key is don't forget to convert your temperature to Kelvin and subtract that extra water vapor pressure from the chart from your P1. Good luck. Let me know if you have any questions.